So when we started with the Sovereign Cloud Stack project, we had this idea that developing standards and developing software should be done together, so we don't standardize things that cannot be implemented in a nice way. Obviously, if you do that, there's one danger, and that danger is that the standards are written such that in the end, only the reference implementation actually can fulfill it and other environments cannot. So we are trying to have a lot of interactions with partners that are not using the reference implementation to make sure they can also implement the SCS standards. And I think we've had some success along the way, and I think Martin will, I guess he'll talk about a number of things, but it's hopefully going to be one of the things he'll talk about as well. Martin from Cloud and Heat will share with us their experience with Sovereign Cloud Stack standards.
Thank you, Kurt, for the introduction. So again, I'm Martin, working for Cloud and Heat Technologies GmbH. And today I want to take you on a journey or experience report with us setting up SCS-compliant cloud with Yaook. So what I'm going to cover in the next 18 minutes, of course, why did we do this? Then maybe not everybody of you will know what is Yaook about. I will have a quick recap of it and give you a quick overview. Then we look back at the timeline of the events, how we got to a fully functional working cloud. We will cover some funny things, for instance, deployment fun facts. We will look on what went well and what went wrong. And I also want to share a nice little success story regarding health monitoring and taming rabbits. And of course, we will wrap up with results and an outlook. So why did we do this? So Kurt mentioned it already. It would be nice if we dogfood our own standards. So we at Cloud and Heat, we were mainly into writing the standards. So we mainly wrote them ourselves. Of course, there were some other people involved, but SIG standardization is basically full of people from Cloud and Heat. And we wanted to show that it's possible that the Sovereign Cloud Stack IaaS standards can also be adopted outside of the reference implementation. And we at Cloud and Heat, we of course love Yaook. We are proud of it. We are involved in its development and we like to use it. And we of course also like the standardization approach of the SCS. So why do we not combine both and document our findings for the SCS, which will be a win-win for all of us, yeah? And of course, you might have known and check this if you were on the SCS Summit this year. Our deployment is actually part of a bigger proof of concept going on with the Föderale IT-Kooperation, which is about a proof of concept transferring workloads between different clouds, different providers, and even of different implementations. So we use Yaook, but there's also another cloud which uses the reference implementation, I think. And the goal is to demonstrate it's possible, because of the standards, to easily migrate your workload from one of these clouds to another. Yeah. So as I've promised, a brief Yaook overview. So some might think it's a little bit insane, but we like to run OpenStack on top of Kubernetes. And this means, in detail, OpenStack control plane and also the compute components are running on top of, typically, a bare metal Kubernetes cluster. And all of the lifecycle management of the components, of the API components, but also of the hypervisor components, is all done by so-called operators. So you might know from Kubernetes, there's the operator or controller principle. And we have individual operators for each component. For instance, if you take Keystone, you can use the Keystone operator. You install it via Helm. And this particular operator is then responsible for managing the lifecycle of this component, but also of all the subcomponents that are needed, like databases, or maybe if you go to Nova, you also need a message queue, and so on, and so on. Yeah? And as I've said, underneath we've got the bare metal Kubernetes, which is also provided by Yaook, but it's then called Yaook Kubernetes. So we have different products in this range. So we have the Yaook operator, which you can see here. It's for the OpenStack part. And then we have Yaook Kubernetes, which is rolled out with a combination of Ansible and Terraform. In the Terraform, of course, not in the bare metal case, but if you want to deploy Kubernetes on top of OpenStack, you can use Terraform. And we use it as a lifecycle management for Kubernetes. Bare metal is a different beast altogether. You need to somehow provision your nodes. And for this, we have yet another solution, which involves Ironic from OpenStack, and yet another controller component provided Yaook, which manages the whole Ironic components and the infrastructure that is needed for having OpenStack Ironic rolling out a bare metal cluster. Okay, and just a quick example. I don't want to go into too many details about this, but I said here everything is declarative. And what I mean by that, you use just a Kubernetes resource, a custom resource. For instance, you use a Nova deployment resource, which comes from our yaook.cloud package. And then you specify declaratively all the things that you need, configuration, like maybe you need a keystone deployment for that you can reference. You configure the database, settings, message queue. You can say how many replicas you want to have and so on. And then the Nova operator will kick in if you deploy this manifest here into a cluster which has the Nova operator running. And it will basically create for you all the components that you need. And it will manage the life cycle of all of these components. And you can also see if you want to have high availability, which comes pretty standard with a Kubernetes cluster, you can easily scale your deployments up. For instance, the Nova API deployment, you scale it to 3 replicas and so on. And we very much like this approach. It has proven to be really cool to manage clusters this way. So then looking back at the timeline, how we built this cloud. So this is actually a pretty new project. And also for me, I joined the SCS in February. So this is one of the first things that I basically did with the SCS. At the beginning of March, we had some initial preparations, and we also did a rehearsal installation on a smaller test cluster, which was also bare metal. And then we took basically a week in March between 11 and 19 and did an on-premise deployment on the actual hardware, which is now also running in production. And end of April 24, we moved this cluster to its final location at Enviatel. It's a company in Leipzig, a local power supplier. But they also have a data center, and and this involved, of course, shutting down the whole cluster and bringing it up again, which has its difficulties on its own, but it worked. And then we got the usual way, configuring the uplink to the internet, making all the OpenStack APIs publicly accessible, like with real Let's Encrypt certificates and so on. We did burn-in testing, benchmarking, and we also installed the health monitoring. And then at the beginning of June, we had our first maintenance upgrade, and we upgraded to OpenStack Z. For you, this might sound a little bit outdated, but it's the way in Yaook. Most of the operators at the moment support Z in the stable mode. Support for later versions is currently under the works. And then the real fun things began. Since June 24, we achieved the SCS IaaS compatible version 4 conformance. And we also began debugging some stability and performance issues, especially leaked Cinder volumes. And I want to share some insights and experience on that later. We solved them, so that's already known, and it's a good thing. And the last thing that we had a field service action at the data center in Leipzig because we had to move to a bigger rack. So we could practice all this shutting down and getting up the cluster again another time, but it worked out pretty well. So now we have a happy and functioning cluster. Okay, I'm on time. Well, so I promised some deployment fun facts. So of course, everything is redundant. So we have redundant firewalls, switches. We have also dedicated switches for different purposes, like for the internode traffic, basically data traffic, for the management traffic, like IPMI and PXE. So for the ironic stuff, when you provision bare metal nodes, then the ironic component requires yet another Kubernetes cluster, yet another bare metal Kubernetes cluster, which is in our terminology the YMC. So it's the Yaook bare metal cluster. It's just a one node cluster. One node is enough. It's not so important to have it in a high availability setting, because you only need it if you want to roll out a new node, a new bare metal node. So it's not that important, but we can extend it later on if we want and join more nodes to that. Then we have 3 Kubernetes nodes dedicated just to the Kubernetes control plane. We have 3 nodes dedicated to the OpenStack control plane, and yet again 3 for storage. In detail, it's a Ceph cluster deployed with Rook. And then we have a number of Kubernetes nodes just dedicated to running the compute workloads. At the moment, 3, but we will extend this later on. And every one of you who knows HTOP will be delighted by this little screenshot. I was certainly very delighted because this is the one of the compute nodes. I never had the pleasure to work with a machine that has so many cores. It was really cool. And also 1 terabyte of RAM. So it's a really, really big machine. And yeah, you wouldn't expect that you have performance issues with it. So, what went well? So I said we had set up an SCS-compliant cloud. And this is the part which went really, really well. So once we had all set up, we had a running cluster, we could really benefit from the good tooling that we had at the moment. So basically, a lot of the stuff that you need is just a pip install away. So for instance, we've got the OpenStack flavor manager, and with it, you can set up the main data flavors that you need, such as this one that I depicted there. It's hard to pronounce. So, and this OpenStack flavor manager has all the batteries included, and you basically have no additional work to do. You just need to find it, and you need to know that you need to execute it. Then you have basically one of the standards already solved. Also, there's another nice tool, OpenStack Image Manager, which you can use to import all the mandatory, which was at the time actually only one, Ubuntu, and recommended images, and which also sets all of the properties that we have standardized. And it's also batteries included, but it's a little bit more difficult. For us, it was not difficult because we were insiders. We knew where to look. But so everything is there. And the next cool thing, which went really well, so the conformance tests, they worked as expected, and we could quite quickly include them into the daily conformance tests, which you can see on the GitHub page, but also on our documentation page. And then we talked about the OpenStack Health Monitor previously. We also installed it, of course. So every cloud which is listed in the SCS-compliant clouds table has a little link HM, which you can click. And we, of course, also provide one. And this health monitor actually provided us some valuable insights for some problems we hadn't had before or haven't seen before. And I will talk a little bit more in detail about that later. Just a little disclaimer, this was easy because we had ideal conditions. We have a greenfield deployment, of course. Sometimes it might be a little bit more difficult, especially if you have already existing flavors or something like that. You cannot easily make an old cloud conformant like you do with a greenfield deployment. And we also had, from the hardware side, really good preconditions. For instance, we have homogeneous nodes, all with the same hardware, all with local SSDs and so on. If you have like a mixture of hardware, it will be a little bit more difficult to achieve. It's not unachievable, and it's not a huge effort, but you have to take a little bit more into it. So what went wrong? I think the first point is just basically for all hardware-related, for bare metal deployments, you always have hardware-related issues. Some simple things which in hindsight are really easy actually, but you stumble over them, like inconsistent BIOS settings, hardware clocks running out of sync, and so on. Maybe some active hardware rates which shouldn't be active anymore. And some of it was partially because we used second-hand hardware for some of the components. And the learning from that is you need to really look into every little bit before you deploy stuff on your bare metal hardware. So just resetting BIOS is not always enough. Another thing that we went into and we had a lot of problems with, we relied too much on default settings in OpenStack and also in RabbitMQ, and it just wasn't suitable for the hardware that we used. And another thing, so while we had no problems setting up and using the tools that we wrote, we noticed that it's actually, it requires some insider knowledge to find everything. So everything was documented from the standards point of view, but we figured out that if you're new to this, and if you're just a cloud service provider who's new to the SCS, but you want to become compliant, it's actually not so easy to find all the bits and fit them together. So just one example, if you have the task to get all the mandatory images into your cloud using the OpenStack image manager, it's not so easy to find the actual list of the images that are required. It's somewhere hidden in a little folder, which is used for the conformance tests. And we also had some thing which is specific to Yaook Kubernetes. We encountered a little regression during the burning tests because we relied on behavior which was standard behavior in Open vSwitch. But nowadays, if you use OVN as the software-defined networking solution, it doesn't work anymore. But things sometimes go like this. So now I want to share in the last 2 minutes, I will make it quick, I promise, a little success story and where the OpenStack health monitor plays a big role actually. So it's still the old version that we have used. So today we heard that there's a new version, but when we set up this deployment, this was the version which was currently the stable version, so we used it. And all of you maybe know this little Grafana dashboard, which every compliant cloud has on our GitHub pages. And you see these little spikes here. And it turns out we had a little problem with our Cinder storage. And I will just show this slide. I have a little bit more detail, but I think we cannot fit it into my time slot. But really, this took us a very long time to get sorted. It's also one of the issues that in hindsight are very easy, actually. So now you know the solution. It's just like, you should have known it from the start. It's, of course, like this. We quickly knew what was the culprit. So we had QE issues in RabbitMQ. And as you might know, the RabbitMQ is the underpinning of all the communication of all the remote procedure calls inside OpenStack. And if RabbitMQ is not happy, OpenStack is not happy. And we knew there was some issue in RabbitMQ, something going on with the queues, but we did not know why this happened. So the symptoms from the user perspective were so-called leaked volumes, which just means you had volumes hanging around which were marked as in use and maybe in attaching or something like that, but the actual instance was not available anymore, so it wasn't actually used. And the problem is now you cannot, as an ordinary user, remove this. You need the help of an admin to remove this, and it also eats your quota, which is bad. So this shouldn't happen. And as from the perspective of an admin, we would see a lot of log messages about reply queues missing and inconsistent state in the Cinder database. I will quickly switch to the next slide. So The solution was, after a lot of digging around and reading source code and so on, the defaults that RabbitMQ uses are optimized for a dedicated node per RabbitMQ instance. And it's highly optimized RabbitMQ, basically. It's really optimized for performance. But in Yaook, we have the microservice approach. You have one dedicated RabbitMQ per service. For instance, for Nova, Cell 1, you have a RabbitMQ. For Cinder, you have a dedicated RabbitMQ, and so on, and so on. And of course, all of this run on our 3 nodes for the OpenStack control plane, and 3 times replicated. So this assumption that the RabbitMQ developers made is not valid anymore. And what actually happened is that in Yaook we have a so-called certificate rotation, which happens every week because every communication inside the cluster is completely encrypted. And we use the cert manager in Kubernetes to have a weekly rotation because there's no other way to revoke certificates. So if a certificate gets away and someone steals it, you have no way to revoke it. So the only solution is to have short lifetimes of the certificates, and that's why we do it so often. And this thing only happened during the certificate rollover. And the cool thing is, only the OpenStack health monitor and the API monitor was able to detect this because it was running all the time. So it was running at Sunday night, like 11 p.m. or something like that, where nobody usually uses the cloud, so we wouldn't have noticed it. We also didn't notice it during the Tempest test that we run, during the burn-in. And the OpenStack Health Monitor helped us finding this issue. So while all of this sounds very, very negative, I must say I'm really happy that we had this tooling at our hands. And another cool thing that I wanted to share with you, it's just the power of open source. So open source allows you to dig into the code and actually find out what's happening. And you also find out, oh, okay, there are other people with the same problems. So you might recognize this name here, Mark Schöchlin. So they had not exactly the same problems, but they had some problems with RabbitMQ. So this is a particular change request for Collar Ansible. Yeah? And also in the upstream, in the Oslo messaging library, which is basically the library which talks to RabbitMQ in OpenStack, there were also some changes in the last year, which tackle problems with RabbitMQ. So it was really actually relieving for us to see, okay, we are not the only ones. Yeah. And this sums up. So this is my last slide. So the results summarized. We have another SCS-compatible cloud. So you can see us here, besides some others, which are also green with version 4, which is really, really cool. We also have a proof it's easy to adopt, or quite easy to adopt, the IaaS standards if you're not using the reference implementation. We have a proof that the tools that the SCS made are really useful. And I do not mean only the standards tools, but also the health monitor, or like the OpenStack image manager, and so on. Previously, I mentioned that we had a little bit, some vagueness in the documentation. We, of course, fixed that. We added some implementation notes, so it will be easier to find for newcomers. And we also had a blog post about our findings. And for the outlook, of course, we want to keep up with the upcoming standards, like maybe volume type standards, key manager standards, everything which comes in version 5 and later versions. And that's it for today. Thank you.
Thank you, Martin. Do you have any questions for? Yeah, Thomas.
Thank you. How susceptible is the original Kubernetes distribution? For example, if I would like to have a very closed solution like Talos as a Kubernetes-based image, would this already be possible, or do I have to adapt something?
Basically, you can. I understand the question is how can you deploy the Yaook operator and stuff on other Kubernetes solutions? Yeah. So you do not have to use Yaook Kubernetes. You can use any other Kubernetes, but there are some requirements that you need to ensure. So there need to be some components installed, but which can work on every Kubernetes cluster. So we have a documentation page in Yaook which shows which versions are supported with Kubernetes versions and which components you need. So, for instance, if you want to use Ceph, you certainly use Rook. You need to install this first. And Prometheus, for instance, is also one of the preconditions. Okay. Cool.
So you partially answered the question I wanted to ask already, because I thought, wow, if you think some of the information is hard to find, why don't you write a blog article to improve it?
Yeah.
Some documentation. And you just mentioned you did. But is there more to come?
There's more to come. Yeah, so I think there's still an issue that we wanted to document this. So we want to transfer this, which is in the blog post, into a documentation page, because blog posts tend to go under the hood sometimes, and nobody updates a blog post. But documentation needs to be updated, and IT moves fast, and you will have things to adapt to. So I think there will be some more things coming.
Good.
Mm-hmm. More questions? Okay, thank you.
Thank you again.